Process capability indices. And what we are going to learn now is process performance indices. So we have sufficient time to talk about it. So I'll take you through the slides. Some of them are basics we already dealt. I'll skip those slides. However, the required slides I will be explaining you. Okay. So process capability analysis. Process capability analysis means we try to understand our potential and we also try to understand the reality, right? What are we capable of and what are we actually delivering? There are two things. What are we capable of is one thing and what are we actually delivering is other thing. So which is important? Your capability is the important or what are you delivering is important? Which is more important?
Okay.
Capability. Yeah. Okay. So I may be capable of many things, but what am I delivering here? That matters to you, isn't it? Always from the customer's perspective, the delivery is important. Nothing but your performance is important. So that's why today we are going to understand another important metric known as process performance indices. They're more powerful than your capability indices. They're more powerful than your capability indices because the process performance indices can help you to directly understand the customer experience, right? To what extent, the customers are happy with your product and service, your PP and PPK can talk better. Okay. So what is process capability? And different yield, these and all basics you have already done. Traditional yield, first pass yield, throughput yield, defects per opportunity, defects per million opportunity, defects per 100 units, defects per 1,000 units, parts per million. These are all known to you. I'm not going to talk about it, but I want to talk about this process performance indices, right? And similarly, process capability indices. Whenever you are talking about all of these things, tools, you are actually, trying to understand the capability and trying to understand the performance, right? So all of them are, somehow they give they take you to the same destination. However, depending on the conditions, the tools will be selected. But for continuous data, we always use this process capability indices and performance indices. But if the data is attribute, yes, we can use all the other. So this yield and all, so output by input and first time yield and throughput yield, all that we are not going to discuss. So this also I will, DPMO calculation we have got you. Yeah. So this is a picture that can help you to understand, your capability. So you see cars parked in different parking areas and which scenario makes you more capable? Which scenario you will be more confident while parking a car? Scenario number 1, scenario number 2, scenario number 3. Which is better?
3.
Scenario number 3.
You will confidently park the car and then you will park it very effortlessly and the chance of failures will be minimal. This is what we refer to process capability. See here, the size of the car indicates the spread of the process. The size of the car indicates the spread of the process. The size of the parking area indicates the customer provided tolerance. Car should be always smaller than the size of the parking area. Yes or no? Yes or no? Car should be always smaller than the size of the parking area. So the spread of your process should always be smaller than the tolerance given by the customer. If the spread is, if your process spread is more than the customer tolerance, definitely failures will happen for sure. If your car is bigger than the parking area, you still wanted to take it inside, what will happen? Your car will certainly get damaged. The quality planning itself is bad. Do you understand? And who can afford to buy a car bigger than the size of the parking area? Is there anybody here? You want to buy a big car and then damage it by putting it in a smaller area? No. So if you are keeping your process spread more than the customer tolerance, there is something wrong at the planning stage itself. So execution will certainly, will definitely go through the failures. Rejections for sure will happen. If repeatedly 5% rejection is happening in your production, where are we wrong? We are wrong at the design itself, the planning itself, there is a problem.
Planning.
Definitely quality control is only, to detect the problems. Detect the problems and then advise on the rework and other opportunities. But you have to correct, our processes. We have to replan. We have to redesign our processes. So that is called improvement, quality improvement. So anyway, so that is the understanding here. So the spread of the process, see for a car, the spread is nothing but the width of the car. Very simple, easy to measure. But for a process in your organization, how will you measure the spread? What is the formula? Do you have any formula? The spread of any process is equal to 6 sigma. Yes or no? You all have studied that. A process will have variation plus or minus 3 sigma always. Upper control limit, lower control limit. So the distance between upper control limit and lower control limit is 6 sigma. Once you calculate 6 times standard deviation, that is the spread of the process. That spread should comfortably fit in with the customer tolerance. If that is not happening, there will be failure. And please note, not only the size of the car matters, your driving skill also matters. Yes or no? Even though the car size is smaller compared to the parking area, suppose you don't have proper driving skill, you can still damage the car. Suppose you are drunken, definitely you will again damage the car. So the driving skill also needs to be understood. In order to understand the driving skill, we look at the process average. All of you understand? The spread of the car, we understand by calculating 6 times standard deviation. And in order to understand the driving skill, we look at process average. If process average is perfect, spread is also smaller, you are creating a beautiful scenario. The plan is fantastic. Yes or no? So if the plan is fantastic, then the results, can be fantastic. But still, some things can go wrong, last minute, issues, and that can be easily corrected with the help of the quality control. But if plan itself is wrong, then definitely no improvement is required. Oh. And one more thing I want all of you to understand here is, if the size of the car and size of the parking area are exactly same, size of the car and size of the parking area are exactly same, you are creating a just capable scenario. You are creating a just capable scenario. That's the time your Cpk will be equal to 1. Your Cpk will be equal to 1. But what is the industry standard? Cpk must be 1.67. Should be 1.67. And for less critical process, it should be 1.33. So just capable scenario, Cpk equal to 1. If Cpk equal to 1, and if the process is just capable, in terms of sigma level, the process is 3 sigma process. So sigma level can be derived from Cpk. Am I correct? If Cpk equal to 1, what is the sigma level? 3. That means you multiply the Cpk value by 3, that will result in sigma level. Am I right? Cpk equal to 1, so sigma level equal to 3. How can you convert the 1 into 3? By multiplying by 3. Suppose if your Cpk becomes 2, your car size is half the size of the parking area. Your car size is half the size of the parking area. Now your process is doubly capable. Your Cpk is 2. That's the time your sigma level can be 6. All of you understand what I'm telling? Do you understand now what is 3 sigma and what is 6 sigma? No, it's very clear, right? And this is the parking area, and this is your car. Now, what is the Cpk? Is equal to
1.
1. What is the sigma level? 3 sigma.
3 sigma.
Why do we call this process as a 3 sigma? See, this car can be parked properly only if it, only if you drive it at the center. Yes or no? So process is centered on the target. Target is always the midpoint of upper USL and LSL. USL, LSL. Process is centered on the target. And now what is the distance between center and the nearest spec? Can somebody tell me?
3 sigma.
3 sigma.
So the process is known as 3 sigma process. The process is known as 3 sigma process when Cpk equal to 2. Not just Cp equals, sorry, when Cpk equal to 1. Suppose my car size is just half the size of the specification. Again, my car is parked properly. I mean, centered on the target. And now my process spread here itself is 6 sigma. Can you see that? But with respect to the tolerance, I'll tell you, with respect to the tolerance, with respect to the tolerance, yeah, let us understand what happens. Yeah. And now my process is centered here. I very well know here itself is how much? 6 sigma, isn't it? My 6 sigma is fitting just by consuming half of the parking area. So I have some, extra space. Since my car is half the size of the parking area, half of the car occupies distance which is equal to 3 sigma. The balance 3 sigma will be here. So overall, center to nearest spec is how much here? 6 sigma. So that is why when Cpk becomes 2, the process is considered a 6 sigma process. All of you understand? Clear? For a 3 sigma process, the guaranteed success rate is 99.73, provided the conditions remain same. Whatever conditions under which you conducted the capability study, if it remains exactly same, the success rate is 99.73. But do you think the conditions will remain exactly same, similar to the time of capability study? Do you think the conditions will exactly remain same even after 3 months, 6 months? The time of conducting capability study, you know the conditions, right? How much time you normally take to conduct a capability study? 2 hours, 3 hours? Whatever conditions remain during the 2 hours, 3 hours, if that is going to remain, throughout the period, then the success rate, you can maintain, the same level of 99.73. But normally what happens is, the conditions during the time of capability study and the real-time conditions can differ. Yes or no? Just think about, the time you performed the capability study in your factory. During the start of the production, you perform the capability study and Cpk are great. But after 6 months, the conditions will be different. Yes or no? The machines have now maybe become a little more old. And there are many other possibilities for variations to occur. So if the conditions are different, then the success rate of 99.73 can drop to 95 or 90. Please note. That is why Cpk are considered short-term measures of capability. Right? So what I'm trying to say is this 99.73 is a short-term capability. But when it comes to the 6 sigma, here we say the success rate is 99.999. This 99.999 is a long-term success rate. That's why it's always a good idea to maintain a Cpk value of 1.67 or 2. Even in the long run, your success rate will be close to 100%. Even in the long run, the rejections will be very, very minimal. Now tell me, If you are okay with 5%, 10% rejections, if you are okay with just short-term success, you can work at the CPK values of 1, but CPK values of 2 can take your success rate much closer to 100%, so that even in the long run, the failures can be minimal. That is the idea. All right. So I think now all of you understand what is the 3 Sigma process and what is the 6 Sigma process in a little more better manner. All right.
Yes, sir.
Okay. So this thinking can now be applied to any process. Just all that required is the data you generate must be a continuous data. So what what do you understand from my slide right now? A pilot is landing his aircraft. Do you think capability measures are applicable for landing process also?
Yes.
Yes.
Is it important to the customer the pilot should have the good capability to land the aircraft?
Yes.
Right.
Yes.
And
Yes.
you see here, so in order to assess the capability of the pilot, I am asking the pilot to land the aircraft, for 100 times. You look at the landing points. What is your assessment now about the pilot? Is he landing properly?
Good.
Yes.
Looks to be good.
Good.
Because you started seeing all your points very, very closer to the expected landing point. Yes or no?
Yes, sir.
Because you as a
Yes.
passenger sitting inside the aircraft, you expect every landings to be, the safest possible landing. The safest possible landing happens at the center of the runway. Similarly, in a manufacturing scenario, the best products are produced at the center of the specification. All right. So now few more landings. And now your point is, you can see little away from the target on the right side. And now few more landings, few more landings, few more landings. Once you have sufficient amount of data,
Oh.
once you have sufficient amount of data, and you will be able to see your data following a specific, pattern. And that is nothing but bell shape. This will happen with, continuous data every time the process is running naturally. Right? This will happen. See, when the pilot is landing, the condition should remain, same. If the conditions are natural, definitely he will be landing like this. Throughout his landing, if there is a big storm and turbulence happening, do you think the pilot will produce data in this manner?
No.
So the process should be free from special causes so that you can expect normality. Process must be free from special causes so that you can expect normality, so that you can apply the properties of normal distribution for your decision making. That is why whenever you see abnormality, whenever you see special causes, we recommend you to stop the process and then understand, identify the root cause. Identify the root of the special cause and then fix it properly. Then only you should proceed. If there are too many special causes affecting your process, and then you can't expect normality. And all your, the knowledge you gained, you will not be able to apply and produce the result. All right. So this is target, this is process average. Please see, we expect the process average and the target to be at the same point. And this is the upper control limit for the pilot's landing process. Can you see that? This is the lower control limit for the pilot. Now you understand the spread of the landing capability, right? And this is the upper spec. This is the lower spec. And throughout the process, the control limits remains inside the specification limit. That means the pilot is, a very, very safe pilot to fly. All the passengers are safe in his hands, isn't it? Even the worst landings are safe landings. You see here, even in the worst scenarios, he still, makes the safe landing. So the target and average should be same. The specification limits and the control limits. Whenever you see the control limits inside the spec, you can conclude the process is capable. The logic is applicable in all scenarios. Suppose you want to shoot balloons. Normally you play this game whenever you go to beach, isn't it? And now suppose if the rule is, if you hit the balloon at the center repeatedly 10 times, you will get 10,000 rupees. Now, all that you need to do is, you must know how to hold the gun. Yes or no? If people don't even know how to hold the gun, if they hold the gun like this, where is the gun pointing? It is pointing the sky. Actually, the gun should point the target. This is what we are checking with the process average. Process average should be on the target. If process average is on the target, you know how to hold the gun. And now once you know how to hold it, you execute your process, uh, in a controlled manner consistently. Now what will happen? All your bullets will hit the target, you can see. You understand the process is controlled effectively, and so consistently your results are great. So two things you need to know. One is you should know how to hold the gun. Another thing is you should know how to keep your nerves under your control. Yes or no? Suppose by looking at the conditions, if you lose control, then what will happen? Your bullets will start slipping away from the center. Yes or no? If you are a poor controller of the process, your bullets, instead of hitting the target, it may start hitting the balloons in the first circle. If you lose further control, your bullets may start hitting the second circle. If you lose further control, your bullets will start hitting the third circle. If you lose the control further, your bullets will start hitting the audiences. Situation is extremely worst now, and nobody will allow you to continue further. This is what we are also saying. Whenever you see a point 3 standard deviation away, situation has become very worst. Your bullets are hitting the audiences. You should not keep quiet. So that's why whenever an observation is found beyond the control limit, we recommend you to stop the process. Yes or no? If somebody is shooting like this, do you think the audience will still, sit and then expect the bullets to hit them? No, they will come and stop. Same thing, you should also do it, right? So that is the lesson here. So quality is a function of statistically, see here, statistical definition of quality. Quality is a function of process average and process standard deviation. Agreed? If process standard deviation is minimal and if the average is on the target, you end up producing world-class products. So the definition of world-class product means process average is on the target and standard deviation is minimal. So hold the gun correctly and hit the target consistently by effective control. So this is why we have taught you normal distribution. Hope all of you now understand, why we should know the properties of the normal distribution. What are the properties you know right now? Normal distribution curve is symmetrical about the center. Yes or no? That means 50% on the right, 50% on the left. You see this property getting fulfilled in many processes. You draw a line here at the center of your face. Do you see your face symmetrical? How that happened? It happened on its own, isn't it? It's no, whenever a process is designed and allowed to run the way it is designed, you can expect normality. You can expect normality in your data, right? So, and then all these rule, 68.27, 95.45, and 99.73. And to the extent possible, it is divided. And whichever is the area of your interest, there is a probability. Can you see that? The brown color area, this area is 13.6. This green color area is 2.1. Where do you want your process to operate? Where do you want to see your control limit, or where do you want to see your specification limit? This is how any process can be described. This is how any process can be described. Now, where do you want to see your specification limit? Tell me. And let me see whether you people are able to think statistically in a correct manner. Now tell me, where do you want your customer target? Tell me, where do you want your customer target? This is the nature of the process. See, customer targets, of course, you don't have any control to change the customer target. Customer can decide. But if this is the nature of the process, and if customer says, this is my tolerable limit on the right, and this is my tolerable limit on the left, you understand you are running a capable process. Am I right? If these are the spec, the center of the spec will be the target. This is the target. Target is always indicated by mu. But this particular point of your process is X bar. X bar is process average. Mu is customer target. You must try to fulfill this condition. What is this condition? Process average equal to customer target. Clear, all of you? If these conditions are not getting fulfilled, your process is under trouble. The process is under trouble. And here is your control limit, upper control limit. Here is your lower control limit. This control limit is nothing but 3 standard deviation. All right. So I think now you all understand, why we are learning this normal distribution. And now in this scenario, is this process capable? This is your upper spec, you see here. This is your lower spec and your process is inside the spec. The process is capable, yes or no?
Yes.
Yes, capable.
Yeah. I change the scenario. And now what your process, can you see your process completely shifting? Because sometimes we lose control, isn't it? We can't have the same control every single minute. We lose the control. Even we lose the control, my process is still safe. Right? Little losing the control by little margin happens for everyone. Agreed? So if you are prepared for that, you are capable not only in the short term, you are capable also in the long term. That's the idea. Now the same problem can happen on the left side. Now what happened? You see, you have a process, but specification ends here. But process spread is far more than the spread of the, far more than the tolerance given by the customer. Can you see the rejections happening here in red color on the right and left? Yes or no?
Yes.
Yeah.
sir.
So the process is clearly not capable and Cpk are lesser than 1. So this is what you learned in Cpk. But please note, now is the time for you to understand the difference between Cpk and Ppk. Though we have two metrics here, Cp and Cpk, which is better? Cp is better or Cpk is better? Which is better? Cp is better or Cpk is better?
Cpk.
Cpk. Because Cpk looks at two things. It checks whether the car size is less than the parking area or not. That's very, very important calculation. Before parking a car or before driving a car on a road, the primary requirement is car size must be smaller than the road size. Otherwise, you should not drive. Am I right? If your car size is not smaller than the road size, you should not drive. If you are not respecting this principle, you don't know what is quality planning. Right? And size of the car smaller than the road is not, enough. The person driving the car should know the driving. Yes or no? The people who are running the process should know how to run the process. How are they running the process? You can judge by understanding the process average. Where is the process average? Is it on the target or away from the target? If the process is away from the target, you can understand people don't know how to drive. The driver is poor. Car is good, but driver is bad. Yes or no? If the process average is far away from the target, then the driver is drunken. Something really, wrong in a bigger manner. You have to do the corrections, right? So this is what, the Cpk is helping you. But please note, in order to calculate the capability, Cp as well as Cpk, we need to know process average. We need to know process standard deviation. And process standard deviation can be calculated in 4 different manner. How many ways we can calculate standard deviation? 4 ways. One particular standard deviation is helping you to calculate Cpk. Out of the 4, one standard deviation can help you to get the Cpk value. Similarly, one other standard deviation can help you to get the Ppk value. If you really wanted to differentiate Cpk from Ppk, you should be able to differentiate the 4 standard deviations, one from each other. Yes or no? If you know how to differentiate the standard deviation, you know how to get Cpk and how to get Ppk. Now I tell you, in order to calculate the Cpk, you must use within standard deviation. You must use within standard deviation. There are 4 standard deviation I told you. One type of standard deviation is within standard deviation. And another type of standard deviation is overall standard deviation. So we will spend some time to understand the exact difference between within and overall. If that is understood, you can calculate both Cpk and Ppk. Otherwise, the formula, everything remains same. See here formula. These are all same, but the sigma should be within standard deviation. Hereafter, you should say within standard deviation. So these things we already discussed, during the Cpk discussion. And see here, what is the formula for Cp? USL minus LSL divided by UCL minus LCL. All the values are available. We get 1.67. And for the same, the process, but now Cp value is still 1.67. Cp still says 1.67, but do you think your process is still capable? No. That is the reason why, Cp is called as a potential measure of capability. It's not the actual measure of capability. Cp is potential because it can only compare the size of the process and the size of the tolerance. It compares the car size and the parking area size. It doesn't check the driving capability. How can we check driving capability? By looking at process average. But in the formula of Cp, there is no average used. That is the drawback with Cp. So to overcome that, we introduce Cpk. And how do we calculate Cpk? By checking whether the driver is away from the target or on the target. The driver can be away from the target by actually shifting the process on the right side. He can also shift the process on the left side. So we check how much shift he is making on the right or left. And based on that, we calculate some ratio, Cp upper and lower. If he is not at all making any shift, he is always driving on the target, the Cp upper and Cp lower will be equal. Moment they become unequal, you understand the driver is shifting on one side. So see here, whichever side the car is shifting, that side failure will happen soon. All of you agree? Whichever side car is shifting, the failure will happen very soon. So we have to capture that side. So we put minimum here. If the car is shifting to right side, then Cp upper will drop. If the car is shifting to left side, the Cp lower will drop. So minimum of the two values is considered as the Cpk value, and Cpk is the best measure of capability because it not only compares the size of the car, which is 6 sigma, it also checks the driving capability of the driver by including X bar. You see here X bar also participating. And now the driver is shifting to the right side. Can you see there is a tendency to shift to the right side? But even then, now the Cpk is found to be 0.8. 0.8 means there are failures happening. Your control limit is expected to exceed the specification limit, but this is not appearing in the picture. But Cpk of 0.83 is a clear confirmation that failures are expected. So these are the conditions to be satisfied. In order to say any process to be capable, you must have a Cpk value of 1.67. All of you agree? Particularly if the process is critical, if Cpk is not more than 1.67, there is a problem with the capability. To say a process as capable, Cpk must be 1.67. If Cpk is more than 1.67, your Cp will automatically be more than 1.67. You don't have to worry. And over and above, this condition should be fulfilled. What is this condition? Cp must be equal to Cpk. If Cp is equal to Cpk, your car is on the target. your process is on the target. If Cp is not equal to Cpk, you can understand the driver is experiencing a problem. He is shifting either to the right side or shifting either to the left side. That should not happen. So these are the requirement. So what are the favorable conditions for a process? Cpk must be more than 1.67 and Cpk must be equal to Cp. Clear? Very good. So some examples here, and I know you will be able to calculate all of these things. And if you know the values, you can manually calculate, or you can put the values in the Excel file I gave, and you can get. Now tell me, Cp equal to 2.22 and Cpk equal to 0.66. What is your opinion? Please tell me. Cp
Process is not
equal to
capable.
2.22 and Cpk equal to 0.66. Now, what is your understanding about your process capability?
Not capable.
I agree, not capable, because Cpk is 0.66. Then what is this Cp is telling you?
It is moved towards the target, like away from the center, but towards the specification limits.
No, no.
Mean
If
is
you
moved.
want to talk in terms of whether the process is away from the target or not, you should look at this condition. Whether Cp and Cpk are same or not. They are not same. So the process is definitely shifted. Right side or left side. You want to look at Cp upper and lower. Which is the smaller value? Cp upper. So process is shifted to the right side. Now, what is the inference of this? Cp equal to 2.22. What does it mean?
The process is having a capability, but we are not
Having
achieving
the process
the
has
potential.
the potential to become capable. Has the potential to become capable. That is the conclusion. So Cp equal to 2.22 means your process has the ability to produce consistent results. What is the ability your processes have? To produce consistent result. But whether the results are consistently good or consistently bad, that depends on Cp. Do you understand? You are writing exam 10 times and all 10 times your mark is, in single digit. Are you consistent now? You are consistent, but you are consistently failing. That is not favorable, right? But your mark should be
Yes.
above 90 repeatedly. Then you are not only consistent, you are also capable. So, Lou, if the CP is good, you can conclude that your results are consistent. But Cpk is good. Your results are not only consistent, but also capable. Your process. All right. So another scenario. Cp equal to 1.11, Cpk equal to 0.66. What is your conclusion now? Your process is capable, consistent.
Process doesn't have the potential to be capable, so some modification in the process is required.
The important process doesn't have the capability. Means, people demonstrate poor control. Right? And so the control must improve. For that, you have to reduce the variation. Ask your people to check everything before that goes into the process. So reduce variation. And then once that is done, then you should move the process mean closer to the target. So both Cp and Cpk will improve. And see here, a restaurant manager is using the tool Cp and Cpk. Do you believe a restaurant manager can use the tool Cp and Cpk? If a restaurant manager can use, then all of you as the professionals in manufacturing and IT and so many pharma, healthcare, you can also use. How this restaurant manager has used the CP, CPK you see here. What is the requirement for in a restaurant? Customer requirement? Food must be served hot. Yes or no?
Yes.
If you are going for a buffet lunch, would you expect the food to be hotter?
Yes.
So how do you know whether the food is hot or not? The temperature of the food. So the temperature of the food is the metric to be monitored and metric to be controlled. And customer requirement is understood. What is the customer requirement? Food should be maintained at a temperature between 39 and 49. The food served in a restaurant should be between 39 and 49. What is this 39? Lower spec. What is this 49? Upper spec.
Of course.
So the target is somewhere in between. But the reality, when I actually collect the data, I understand the food temperature is 40 degrees Celsius in the restaurant with a standard deviation of 2. Now you have to judge whether the process is capable or not, whether the hotel is meeting the customer requirements or not. So see here, they are calculating the values CPK. And what is the CPK here?
0.166.
0.166.
So that means what do you understand out of it? Process is not capable. Process is not meeting the customer requirement. Customer expectation is food should be between the temperature 39 to 49. But every time customers are coming, the temperature of the food is found below 39. Most of the time, the food temperature is found below 39. Can you see that?
Yes, sir.
Hope all of you understand how a restaurant manager can use the Six Sigma tools.
Yes, sir.
So you all now can be a good consultant to Talapakati Biryani and Adyar Ananda Bhavan and explore your opportunities, right? Tell them there are many things you can do for them and which can, finally bring more customers to them. All right. So this is another question. CP equal to 0.94, CPK equal to 0.3. That means process is not capable also, not consistent also. You have to take two actions. You should reduce variation. At the same time, you should move the process mean towards the target. So this is about your CPK. Clear all of you so far? Everything is good? Okay. And now in my slide, you see who is this? Virender Sehwag, right?
Yes.
And this is your sky,
Surya
Surya
Kumar
Kumar
Yadav.
Yadav.
Yeah.
Suppose if you are given the capacity to choose one out of the two and put that person in the Indian team, whom you will recommend? Will you recommend Sehwag or Surya Kumar Yadav?
Sorry, Kumar
Sehwag.
Yadav.
Sehwag.
Why you are avoiding Sehwag?
Because
Performance.
of age factor.
Sehwag.
Because of the age factor. He had all the capability, but he lost everything now. Yes or no?
Yes.
Out of all.
He had all the capability, but he lost everything. However, Surya Kumar, he has the capability and also demonstrating the capability in the form of performance right now. So looking at capability alone and making a decision, sometimes your decision can go wrong. So the better metric to look at is look at the real performance, not just the capability. Same is the comparison. Kapil Dev and Bumrah. Both are good bowlers, but we need Bumrah to represent Indian team, not Kapil Dev. So if that is the scenario, all of you should look for a higher PP Ppk, not just higher CP Cpk. Do you understand? Agree, all of you?
Yes.
It's not
Yes.
that easy for Kapil Dev to remain fit and then bowl at the same speed today. Yes or no?
Yes.
That's why Dhoni is also now retired from Indian team. It's not that easy for to maintain the same control. So we should be prepared to monitor and the decide based on the performance, not on the capability. So I'm introducing another metric now, PP and PPK, because finally your customer will feel the performance, not your capability. Customer will feel your performance and not the capability. Capability only you are calculating, but the customer feeling is performance only. So the only difference between PP, PPK and CP, CPK is the standard deviation. See here, formula wise it is same. You see here, USL minus LSL by 6 sigma. But here the sigma is not your within standard deviation. This is overall standard deviation. Clear all of you? And the formula for overall standard deviation I have given here. And I just have to give you the formula for within standard deviation. Then you know how to differentiate CP, CPK and PP, PPK. So formula wise it is same. See, when it comes to capability is a function of the process variation and the position of the center. And broadly, there are two types of capability, short-term capability and long-term capability. Short-term capability measures are CP, CPK. and long-term capability measures are Pp Ppk. And there is another terminology. We call Cpk as the capability measures, Pp Ppk as the performance measures. You can also call them as potential measures and Pp Ppk as actual measures. And see here, Cp, in order to calculate Cpk, you remember I told you there are 4 types of standard deviation exist. Within standard deviation, between standard deviation, you can combine the two, so it becomes combined standard deviation. And there is one other standard deviation known as overall standard deviation. Now, out of the 4, if you use within, you get within capability. If you use overall, you get overall capability. If you use between, you will get between capability. If you use combined, what is combined? You are combining within
Both.
and between. This is known as within between capability. If you understand the meaning of each and everything, then you can try to use them in your workplace. Right? So now we will make an attempt to understand within capability and overall capability. And with the within capability is what normally called as CPCPK. The overall capability is what normally called as PPPPK. We'll understand that with a case study. And I'm showing you the formula. Formula wise, they're all same. The difference lies in the standard deviation. And one more piece of advice to all of you. Whether you calculate CPCPK or PPPPK, the primary requirement is the control chart should be stable. If the control chart is stable, then only you should perform the test. If the control chart is unstable, you should not perform the test. Yes or no? Imagine you are a no, driving license inspector, and person is bringing a vehicle and for obtaining driving license, and you see that the person who applied for driving license is drunken. Would you like to perform the test now? If you allow him, he may pass, but you will not allow him. Yes or no?
Yes.
Yes.
That is the logic. Whenever you are conducting capability study, if the control chart is unstable, if you see lot of points outside the control limit, but you still perform CPCPK study and PPPPK study, means you are allowing a drunken person to take up the driving license test. Yes or no? You are not correct, isn't it? You are logically wrong, and that mistake you should not do, right? So process must be in a state of statistical control to perform the capability analysis, be it CPCPK, be it PPPPK. The primary requirement is statistical control. Then only you can conduct the capability study, otherwise no. Okay. Now is an example, a case study. Imagine a company has to produce a component, and the component is nothing but a component comes is a metal plate. Let's say it's a metal plate on which you are applying some coating, on which some coating is done. The coating thickness should be 50 micron. The thickness of the coating should be 50 microns plus or minus 3. Now, what is the upper spec?
53.
53, and lower spec is 47.
Okay.
The raw material comes in the form of a big roll. The raw material comes in the form of a big roll. Once the roll is loaded, it is cut into pieces, coating is applied, and then QC check is happening, and then item is getting dispatched. A roll of raw material can produce 5,000 parts. And once the 5,000 parts are produced, it is packed and then dispatched. Do you understand how the process is going on? A roll is loaded, cut into 5,000 pieces, coating is done, quality check is happening, and then the 5,000 pieces are ready for dispatch. So in this manner, there are 25 rolls loaded. 25 into 5,000, 1,25,000 parts. But in order to understand the quality of the 1,25,000 pieces, it is very difficult to go for 100% inspection. So company has decided to go for a sampling inspection. So from roll number 1, they picked up 3 samples. You see here, from roll number 1, they picked up 3 samples. Now, what is the sample size or the subgroup size? 3. Now, in this manner, for every role, a random sample, a random sample, a subgroup of 3 samples are taken randomly. A subgroup containing 3 samples are taken randomly for every role. So totally you have 75 data grouped under 25 subgroup, and each subgroup represents the parts produced from each role. All of you understand? This is the data collection plan. Are you happy with the data collection plan? Right?
Yes.
The order is 1.25 lakh pieces, and you processed all 1.25 lakh. And look at the way the sample is collected. The data collection covers the complete spread of the production. Can you see that? The data collections covers the spread of data collection is good. All samples come from all 25 roles. And then one role, for one role, how many times you are taking sample? Only once. Yes or no? For every role, you have taken sample only once. And now you should have a convincing answer for this. Why the frequency of sampling is very low? If that is acceptable, proceed. If your common sense says you have to take more samples, then you have to increase the frequency of sampling. For every role, you can take the sample 3 times. Nobody is going to stop you. Do you understand what I'm telling? That judgment you have to make. So the spread of data collection is decided. You are quite happy about it. The frequency of data collection is decided. You are quite happy about it. And now comes the sample size. And sample size, the guideline is always 2 to 25. What is the sample size followed here?
3.
3. Sample size followed here is 3. Do you understand here? Right? And but the range available is 2 to 25. And here the rule is more is better. Instead of 3 samples, you take 5 samples. Yes, that is a better scenario. But normally it is between 2 to 25. Now, some calculation we need to do. The number of subgroups is 25. All of you understand this? Subgroup size is 3. So total number of data 75. Now you need to calculate the range for each subgroup. This is known as variation within the subgroup. The range calculated from each subgroup is a measure of the variation of the parts produced within each role. How many of you understand my statement? For every subgroup, you calculate a range, isn't it? What is range? Maximum minus minimum. If the range is very, very small, what does it indicate? The variation in the subgroup is minimal. If the variation in the subgroup is minimal, then the variation in all the 5,000 parts produced from the role is also considered minimal, because the sample is a representative of the population. Here, sample is nothing but every subgroup. Every subgroup represents 5,000 parts produced from the particular role. Now the range represents the within variation, right? So I calculate range for every subgroup. Since there are 25 subgroup, I calculate 25 range. Now the information of within variation is available in the form of the range. I want to express that in the form of a standard deviation. So there is a formula. The standard deviation is equal to R bar by D2. What is R bar? Average of the 25 ranges. Average of the 25 ranges, R bar, divided by D2. D2 is a statistical constant that depends on subgroup size. What is your subgroup size? What is your subgroup size?
3.
3.
3. And look here, there is a table of statistical constants for control charts. There, for a subgroup size or sample size of 3, the value of D2 is prescribed, 1.693. Use that value, calculate the R bar, divide the R bar by D2, you will get a standard deviation. This is known as within standard deviation. How many of you understand the calculation behind within standard deviation? All of you, right? Yes or no? We calculate the variation within each sample, variation within each subgroup, and then combine it so that we can understand the standard deviation of the whole process. The within standard deviation of the whole process, right? And that is found to be 0.4. If you use this 0.4 in your formula, you will have the formula for Cpk, isn't it? Use this 0.4, that will straight away give you Cpk. Look at your Cp, 2.46. Look at your Cpk, 2.37. Are you happy with it? You're extremely happy because your requirement is 1.67, but you got all about 2. It's fantastic scenario. But now, for the same process, there is one other way of calculating standard deviation, which is known as overall variation. What is overall variation? Overall variation means, you have totally how many data points you have? Totally how many samples you have? Every subgroup you have 3 samples.
75.
75. I want you to type all 75 data in a single column and calculate a standard deviation using all the 75 data in one go. Use this formula. And look, what is the standard deviation you are getting? 0.8. When I calculate the variation, subgroup wise, the standard deviation is only 0.4. But when I combine all the data and calculate the overall standard deviation, it is 0.8, almost double the size. Can you see that? That means see, sigma is a direct measure of the uncertainty. Please note. If sigma is increasing, that means the tendency for your process to lose the control is very high. So now the sigma is 0.8. That means in the long run, the process can lose the control and some adverse results, you may see. Do you understand? So if you use this standard deviation, which is overall 0.8, use the same formula. Now look at your values, 1.19 and 1.15. If you use overall standard deviation, you are now having PP and PPK. Now, what do you understand out of it? Can somebody tell me? PP, PPK looks unacceptable. Can you see that? Because we see same rules for PP, PPK. 1.67 for critical process, 1.33 for less critical process as per the guidelines of AIAG, the Automotive Industry Action Group. So, PP, PPK looks unacceptable. But now, what do you understand?
The process deteriorate over a period of time.
The process has a tendency to deteriorate over a longer period of time. But whatever we saw is okay right now. See here, as of now, according to the data, our CPCPK is great. But suppose, what is your order quantity? 1.25 lakhs. Suppose if your order quantity is not 1.25 lakhs, your order quantity is 1 crore 25 lakhs. Do you understand the difference now? For 1.25 lakhs, things are going well because you have taken sample from all 1.25 lakhs. But if the customer order quantity is 1 crore 25 lakhs, 1.25 crores, do you think you can run the process in the same manner? Can the same process help you to produce 1.25 crore parts? Tell me. Maybe possible. You have to conduct the capability study more frequently. Maybe possible. You have to conduct the capability study very frequently. Every week you may have to conduct the capability study. If you are happy, go. But if you just want to study the capability in one go and take a decision, now it is better to look at PPPP. Yes or no? Imagine your company is asking you to perform an audit for one of the supplier. There is someone who is supplying some child parts to you. Now your company is sending you to expecting you to perform an audit. And now tell me, if you are performing an audit, would you like to assess the capability in one go, or will you go for audit every week? Come on, all of you.
One go.
One go. So which is the metric you should look at now?
PP, PPK.
You must. So at least you get a better estimate of the capability. If you are the auditor and if you have to assess the capability in one go, yes, necessarily you must look at PPPPK. All of you understand? And when you are going for the audit and you want to assess the PPPPK in one go, and now how will you perform the audit? Will you just refer the audit report already prepared by the supplier, or would you like to collect the samples yourself? Come on.
Collect the sample.
Ourselves only.
You have to
Collect
collect
the
the
sample.
sample yourself because already you are taking the risk of deciding everything in one go. And then now if you allow them to prepare the report themselves, then it is not fair. But are we doing all of this? Are we practicing all of this? In real time, we just go and then look at the papers and come back. Yes or no? So we need to improve on the quality of the audits. So, but at least what you can do is you can dictate them how the sample must be collected. Yes or no? You can dictate them and how the sample must be collected. Suppose you have dictated to collect samples for the last 7 days of production. And if the data is available and a report is giving a very convincing kind of values for both CPCPK and PPPPK. Before trusting on the CPCPK as well as the PPPPK, you must ask for their control charts. You must ask for their control charts. Control charts should be clean, should be free from special causes. And control chart you can ask not just for the 1 week, for the longer period you can ask. Do you get my point? Your 1 week data control chart should be one side, and anyway they are producing continuously, isn't it? So the past data control chart, you can ask. In the 1 week thing, absolutely there are no special causes. But look at the past. If the past control chart has a lot of special causes, what do you understand now? Your 1 week control chart is free from special cause. But the last 3 months control chart has a lot of special cause. What do you understand now?
There
It
are
is the
new
same process,
causes.
right?
There are new causes that is disturbing the process.
The last 1 week control chart is free from special cause. But if you look at the previous 3 months, the control chart has a lot of special causes. That means, they are hiding something. Yes or no? If it is the same process that is running, then the behavior has to be same. They might have removed all the special causes. Can you understand that? So, I mean, they might have removed all the out of control points. Yes or no?
Yes.
Otherwise, out of control
Yes.
points will appear in the 1 week data also. Because that is how the process is planned. It keeps on giving out of control points for every single week. But now this week also it should come. Point number 1. And point number 2, if they have removed the out of control points, they must have the action taken report for every out of control points. You can ask for the action taken report. They may say, sir, we have worked, we have improved everything. That is why this week, we don't have any special cause. Okay, agree? But according to the past 3 months, there are 10 occasions special causes are appearing. Can you show the action taken report for each of the special cause? If they really have the action taken report, now there is a chance that your current week control chart can be free from special cause. Do you understand, all of you? If action taken report is available for special causes, you can believe their data. But to the extent possible, you please collect the data, or otherwise, definitely you must refer the control chart, and control chart should be stable. And at the same time, if there are any special causes, action taken report should be available. If all of these things are there, then you can trust on the CPCPK as well as the PPPPK. Clear, all of you? But don't worry, all these calculations you don't have to do manually. And look here, I'm just showing you a control chart. Now tell me, what is your understanding on the process? Is this process operating in a stable manner? Is it under statistical control or out of control?
Out of control.
And in this scenario, will you perform a capability study now?
Yes.
No.
If yes means, under what conditions you can perform capability study?
One sample.
See, your process control chart is like this. So many out of control points. Now you have to perform a capability study. This is like, the person has applied for a driving license, but today he has come in a drunken condition. Will you allow him to take up the test?
No.
Then same is your process is also in a drunken condition now, unless and until, he becomes stable. You cannot. So your process will become stable only if actions are taken on each of the special cause. Yes or no? If action taken report is available, you can perform capability analysis. If action taken report is not available, the process is not eligible for any test. All of you understand? Even if you perform the test, even if you get a great Cpk value, it has no meaning at all. It is like issuing a driving license to a person in a drunken condition. Only you are wrong. Do you understand? So Cpk has no meaning if the process is operating in a out of control fashion. All of you understand? But still you want to believe in that Cpk, it is up to you. But you are not correct. All of you understand this?
Yes, sir.
All are out of control scenarios. Actions are required. Stoppage of the process required. Actions are required. Corrective action should be put into place. And then only the process qualifies for any test, any kind of capability analysis. And this is how the Minitab report will look like. Right? So see here, Minitab talks about two capability. One is actual capability. In the bracket, you can see overall. Look at the Ppk. The other one is potential capability. And where there, it gives the Cpk value. And Z bench is nothing but sigma level. Z bench is nothing but sigma level. All right. And how much is the Z bench? Sigma level? How much it is?
7.1.
7.1.
7.1 is 3 times 2.37. Am I right? 7.1
Yes.
is 3 times
Almost. Yes.
2.37. So you now understand how to calculate sigma level from Cpk value. And you very well know how to calculate Cpk. So we'll do the same problem with respect in Minitab also, and then you will be very clear. See here, any process, there are two types of capabilities possible. One is actual capability, the other one is potential capability. Which one you really want to know? That is the clarity has to be there. If you just want to understand your potential capability, you look at Cpk. If you want to understand your actual capability or the long-term capability, then you must look at Ppk. See, for the same process, I will show you the kind of rejections. You see, ppm. What is the ppm with respect to Cpk?
0.
0.
But with respect to your Ppk, look at your ppm. How many
393.
parts you are likely to reject?
393.
393 parts you are likely to reject according to Ppk. If each part is, let's say 1,000 rupees, then 393 into 1,000, you may lose 4 lakhs. Do you understand? The cost of poor quality may be 4 lakhs, right? So Ppk gives, measure of your long-term capability. Even though there are no rejections according to your current data, still there are likely chances of you producing rejectable parts in the long run. That is 393. According to all the model exams you have written, you have, all good mark. But in the final exam, still there could be a chance. Yes or no? We are just predicting. Please understand. Imagine you have wrote model exam 10 times. In all 10 times, you have passed the exam. Does it mean you will pass the final exam also? Chances are more, isn't it? Chances are more to pass the final exam. But still, by looking at the variation within the marks of your 10 model exam, you can expect the uncertainty in the final exam, right? So the same thing we are doing here. Even though there are no rejected parts currently, it doesn't mean that absolute zero rejection will continue. In long run, rejections can populate. We are estimating that chance of rejections populating from the standard deviation. Since there is a huge difference in the standard deviation you see within and overall, double the standard deviation is seen in the overall. So in the long run, there is definitely a chance of rejections populating. So this is a Minitab report. I will just show you how you can do all of this in Minitab. All right. So okay, any questions, please be ready. I'll be happy to explain. So I'm sharing my complete screen so that we can see how we can okay. So I should just open that sigma level calculator so that the data is available. See, if you have any data, we can do it in the same manner. So we have to go to the coating thickness, right? So just check for coating thickness, should be available. Available here. See, I have explained how to perform all these calculations manually. If you have time, please go through my manual calculation. Otherwise, I want you to copy this data and paste it in Minitab. All 75 data, Control C, and then you can go to Minitab. And now you should be able to see my Minitab screen. Okay, paste it here. Now, where is my data available? Column number 9 and column number 10. Column number 9 gives the coating thickness. Column number 10 gives the roll number. And now we need to perform the capability analysis. So go to stat, go to quality tools, go to capability analysis, go to the normal. Stat, quality tools, capability analysis, and then normal. And now data are arranged in single column. Am I right? Our data is arranged in single column. Which column? C9. So click and select. And subgroup size. What is your subgroup size? Subgroup size?
3.
3.
That means roll number 310.
Yeah.
3.
And what is your specification? Lower spec?
47,
47. Upper spec? 53.
53.
If you give all this, give OK, and now the capability report is ready. Now you can see the customer requirement and how is your process performing. Now you understand the size of the road. Can all of you, do you see the size of the road here?
Yes,
Can you also understand the size of your process?
yes.
And now the Cpk values are, what is this actually? What is this size?
Actual.
This is the road.
Size of the road. Size of the road.
This is the road. And this is your car size.
Actual.
But in the long run, your car, size can come up to this. Your car size can increase in the long run. That means, your driver can take your car to the extreme right side of the road, also to the extreme left side of the road. Can you see that? Is it possible or not?
Possible.
By looking at the driving capability and the size of the car, I judge during, the several thousand kilometers of ride, the driver might take the car close to the right extreme of the road, also close to the left extreme of the road. So the chance of derailing from the road is there. Can you understand that? That is what we are understanding. So CPCPK is 1.19 and 1.15. Sorry, PPPPK. However, your CPCPK are 2.46. Can you understand the within here, meaning of within, meaning of overall? Your capability for within the role, we are checking. Similarly, your overall capability also we are checking. Any questions to me? I'm okay to answer. Or anybody would like to share your Minitab screen and then perform the same thing just like how I perform? Anybody would like to make a try? Because you have everything, no? Whatever data is available, Minitab is available. You only have to just click the buttons and you should be good at interpreting the analysis report. And let me show you now how the control chart will look like for the same scenario. That's very important. So I show you. You see, I'm again showing you the same thing. Now, what is the control chart I should plot? Can you guide me? What is your metric?
Coating thickness.
So which control chart I should go for?
Normal.
X bar, not R bar. X bar R chart. Why X bar R chart? Because subgroup size is 3, less than
3.
8. So control chart, where should I go? Should I go to graph or stat?
Control chart.
Where the control chart will be available? You're learning and forgetting everything on the same day, right?
Graph, sir.
Start.
Stat,
Start.
then quality.
Control chart.
Okay.
Control chart.
Control
Then
chart.
quality tools.
Stat, control chart, not quality tools. Stat, control chart, then variable chart for
Subgroup.
subgroup, then X bar R. So more than the capability, performance matters, right? More than you study, you should remember everything. All right. So X bar R chart. And now come here. Observation are in one column. Yes, we have everything in column number 9. So double click. And subgroup size 3.
3.
X bar R option. Test. How many out of control scenarios you want to test? Definitely special cause means anything falling outside control limit is a special cause. This you must tick always. Over and above, if you know any other additional way of testing the abnormality, you can add. I think today you will be seeing in the control phase, today or tomorrow you'll be seeing that the other out of control scenarios. Now I give okay. Now tell me, is this process under statistical control?
No. No.
Out of control, but you have issued the driving license. But the person is a drunken. But then now to accept the capability report, what is essential now? What is essential now? For each of these out of control point, action taken report should be available. Yes or no?
Yes.
If you are going for an audit and they are projecting you a very good Cpk, very good Ppk, but then you are plotting a control chart and you come across all of this, then what should you ask for?
Action report.
That's all. Right? Suppose if they show you a clean data where control chart also doesn't reveal anything, then what will you do?
Go for
Either
sample.
you should believe them, either you should believe them, yes or no? You should accept that they have a healthier process, or if you are still doubtful, what will you do further?
Personal sampling.
Oh, beautiful. All others must clap now. Fantastic answer. You take a sample yourself, isn't it? That's your point. And see whether your samples also align with this control chart. Those samples should also align with this control chart. That means, it's a fantastic company to believe. You can believe on the process and renew the contract and do everything. All of you understand what are we doing here with the Cpk, Pp Ppk and control charts? All the tools, are for your decision making. They're all available. But how can you use the tools? It is in your hand. Many people simply look at Cpk and then, come back. That's all. They don't look at control chart. Right? But some people like you, they can definitely look at Cpk, also control chart, also ask for the action taken report, also go for the personal sampling. Ultimately, if somebody is lying, we can detect it easily. Yes or no?
Yes.
Once you ask for all of these things, they will become very, transparently accepting everything. Then finally you can take a call whether you want to work with him, for some more 3 months or not. So your decisions, just cannot go wrong easily if you learn to use all these tools. That is the point. That's all. Is it helpful? The knowledge on the Cpk and Ppk.
Yes.
The restaurant
Yes.
manager can use these tools in his restaurant. Think what you can do. You can do a lot. You deal with somebody, no, people say, I deal with so much data. If you deal with so much data, then, do all of this. All right. So that's it. If there are any questions, you can ask. Otherwise, we are good to proceed for the lunch. Though I delayed your tea break, I think lunch is happening at on time.
Sir, if the CP is less, we need to change the make changes in the process
If
to
CP is
make CP.
less, if CP is less, then variation is high. Variation is on the higher side. That means control is poor. So you must focus on reducing the variation.
Should we conclude that the machine is not accurate
No,
to?
no. See, that requires deeper understanding on the situation. See, 9:30 the session, the 2 o'clock the session is supposed to start. All of you are expected to come by 2 or before 2. Yes or no? If
Yes.
somebody comes at 2 o'clock, somebody comes at 2:10, somebody comes at 2:30, somebody comes at 4:30, it's a poor control. And now we cannot guarantee on anything. Yes or no? So how can I gain the control now? We put a additional warning message in the WhatsApp group. Now the time is 1:50. You are expected to join the session in another 10 minutes. Then what will happen? All the people will start joining the session on or before
Advance.
2 p.m. Isn't it? So now when I increase the control measure, can you see the variation going down? As the variation goes down, my CP will improve. If my CP is better, my process is ready to listen to me. If all of you join back sharp 2 p.m., we believe that you are all very much interested in listening to us. And so the afternoon speaker can also happily deliver the session. But if you people are joining at different time and all of you are going off the camera, then the trainer's effort will go in vain. Whatever he speaks, that actually cannot serve the purpose. So whether the process is ready for the improvement or not, CP can answer that question. So CP is not satisfactory means variations are high. Your process is not even ready for any improvement initiative. Make it ready and then go for the improvement. Till then, don't make any special changes. Clear? Have I answered your question?
Yeah, one more additional question. Sir. If the process is statistically stable only, we will be calculating CP and CPK.
That is also correct. Yeah.
So in that case, CP should not be.
See, if the process is stable, you are
Can
calculating
can others
CPCPK,
move?
then in that case, your CP, will be healthier. See, your CP will be healthier if your process is stable and if variations are less, right? Variation. One more. Please note, if you look at the control chart, we only talk about control limit and the points. Am I right? But if you talk about CP, your USL and LSL also comes into picture.
Correct.
So even though your process is stable, still, your what do you call your CPK can be in trouble. Please note. Because with respect to the specification, see in control chart, we only check whether the points are inside the control limit or not. But we don't check whether the control limit is inside the spec or outside the spec. Your control limit can be if your control limit is outside the spec, what do you understand? Your CP is poor. So even though your control chart is in a healthier condition, you still may have your CP in an unhealthier condition. Possible. You have to take a deeper look and digest all your learnings and upgrade your DNA. Then all will be right.
Sir, just one means guidance here I need. So I'm just trying to map a X bar R chart.
Please
So
put.
on,
Okay.
yeah,
Yeah, you
so
share
make
your
it.
screen.
Yes, I'm just going to share
Yeah,
that.
you can do it.
Okay.
Okay, you have data, some data, very good.
Yes.
Observations are placed in just one column only, correct? And click in that white color box. Yes. Now you select your data.
From
But
here?
which control chart? Which control chart? It is X bar or A?
Yes.
Okay, what is this mini tab? 17 or some other version?
17.
Okay, why is it not showing subgroup size? Okay, select the data. It should ask for the subgroup, no? Double click or click and select.
Yes.
Go to X
Now?
bar R option. X bar R option. Minimum number of columns 2. Oh, I think this is not 17. Okay, now then I doubt, I think there is a problem. Subgroup size has to be declared. Okay, you select the C2 also, column 2 also. You place your cursor here. No, both. You select both.
Okay.
Delete that. No, first you delete subgroup first. In the white color box, you make it blank. Select both. But I still doubt whether it will work or not. Click and select. No, both. Now you select. Press the select button.
Sir, is using the option as single row, sir. Subgroup size in single row. So it won't allow you to.
Oh, sorry. Correct. Please change, sir. Yeah. Observation of a subgroup or in one row. No, one
row.
column. Correct.
Yeah.
And now it will come. Correct. So now you click in the white box.
Yes.
Click in the white box and
And
choose the
data.
data. Double click.
Select. Yeah.
And now subgroup size can be given. Go to X. Okay. All other
Already
things.
defined 3, sir. Yeah.
So
Okay.
now,
X bar R option. Test. What are the tests you want to include?
Go to the test.
See, the tests are designed based on the normal distribution. The more you understand, you will be able to select other tests. Okay, you give okay. Only one test. Again, okay. Now your control chart is ready.
yes. Thanks, sir. Thanks,
All
sir.
right.
Yeah,
Okay.
practice so that further any kind of doubt comes, I will get back to you.
Use it.
Most welcome.
Thanks.
All right. So this completes our discussion on